Welcome to this video on chemical families. Knowing the properties of each chemical family on the periodic table will help you utilize it more effectively. The lesson objectives are to identify and explain the properties of key chemical families, including alkali metals, alkaline earth metals, transition metals, halogens, and noble gases. The periodic table displays elements in order of increasing atomic number and organizes them by chemical properties. This arrangement in a periodic pattern allows us to predict an element's trends and behavior based on its position. The periodic table can be broken down into sections to study elements' physical attributes and behavioral patterns based on their location. The periodic table is arranged into 7 periods, which are the rows, and 18 groups or columns. Groups are also called families because elements within them share similar chemical properties. Groups are numbered 1 through 18, or 1 through 8, with A or B notation. A notation is for the main group elements, the tall columns, which show the clearest periodic patterns. B notation is for the short columns. Chemical families also have names. Group 1A are alkali metals, 2A are alkaline earth metals, 7A are halogens, and 8A are noble gases. Groups 1B through 8B are known as transition metals. The periodic table's arrangement helps predict physical and chemical properties. These include physical state, melting point, density, metallic character, reactivity, and valence. A zigzag line beginning at boron divides the table. Metals are to the left, nonmetals to the right. Metalloids, or semimetals, are along the line and possess properties of both metals and nonmetals. Metals lose electrons to form cations, which are positively charged. They are lustrous, good conductors, malleable, and ductile. Nonmetals gain electrons to form anions, which are negatively charged. They are often gases or brittle solids and are typically poor conductors. Elements in the same group have similar chemical properties. For group A elements, the group number equals the number of valence electrons. Valence electrons determine the element's oxidation number or charge, which is positive if electrons are lost and negative if gained. Reactivity depends on achieving an octet, which is 8 valence electrons. Noble gases naturally have an octet, resulting in extremely low reactivity. Other groups gain, lose, or share electrons to achieve an octet, leading to higher reactivity. Noble gases, group 8A, are gases at room temperature. They are relatively inert because they have full valence shells, meaning they typically don't form ions. Examples include helium, neon, and argon. Halogens, group 7A, are highly reactive nonmetals with 7 valence electrons. They gain 1 electron to achieve an octet, forming ions with a -1 charge. They are highly electronegative and form ionic or covalent bonds. Alkaline earth metals, group 2A, are highly reactive metals with 2 valence electrons. They lose these 2 electrons to attain an octet, resulting in a +2 charge. They form oxides, ionic bonds with nonmetals, and bases with hydroxide ions. Alkali metals, group 1A, are highly reactive metals with 1 valence electron. They readily lose this electron to attain an octet and form ions with a +1 charge. Like alkaline earth metals, alkali metals form oxides, create salts through ionic bonds with nonmetals, and form strong bases with hydroxide ions. The alkali metals include lithium, sodium, and potassium. Groups 1B through 8B are the transition metals. They exhibit a transition in oxidation numbers and can form different compounds with nonmetals due to varying charges. They are less reactive than alkali or alkaline earth metals,